In this lecture, we're going to discuss what a homogeneous catalyst is. Homogeneous catalyst is when the catalyst has the same state or is in the same phase as the reactant. So if the reactants are aqueous, then the catalyst has to be aqueous as well. So if it's in the same phase, then we call it a homogeneous catalyst. Now, one example is when we add a catalyst to this particular reaction. The following reaction which I'm going to construct, and I've taken two equations from the data booklet. One is of S2O8 2 minus, which gains 2 electrons and forms SO4 2 minus, and I2 plus 2 electrons, it's forming 2I minus 1. Now I've taken two equations from the data booklet, and I have the relevant E0 values. So I've taken two reduction potentials. Now, since 2.01 volts is the higher E0 value, that means it's going to get reduced, it's going to gain electrons, so it ends up gaining electrons. Whereas I minus 1 has the lower E0 value, so it ends up losing electrons. So S2O8 ends up gaining electrons, 2 electrons, whereas I minus 1 ends up losing electrons. So if I write an overall equation, the overall equation is going to be that you will have S2O8 2 minus, and it's going to gain 2 electrons. It's going to be converted into SO4 2 minus. Whereas I minus 1 is going to end up losing 2 electrons. So 2I minus 1 ends up losing 2 electrons and it gets converted into I2. So that's your overall equation. And the E0 cell for this particular reaction is going to be the higher potential minus the lower potential. So it's going to be 2.01 volts minus 0.54 volts, which comes out to be 1.47 volts. And this is a very high E0 cell, which means that this reaction is supposed to be very feasible. So the E0 value is suggesting that this reaction is very feasible because you have a very high E0 cell. Now, in reality, what happens is that this reaction does not occur. And the reason it doesn't occur is because it has a very high activation energy. Both of the ions are reactant ions. They are negative ions. Since both reactants are negative ions, so what happens is that the negative ions are going to repel each other, so they're never going to reach each other. You would have to give them a lot of kinetic energy so that they can collide with each other. So they're not going to collide with each other. So they will repel each other. They're not going to attract each other. And this leads to a very high activation energy. So you have a very high activation energy. So although this reaction is supposed to be very feasible, the E0 cell of this reaction suggests that this reaction should happen, but due to the high activation energy, this reaction does not happen. So what you do is you add an Fe2 plus or an Fe3 plus catalyst to it. It could be either Fe2 plus or Fe3 plus. It could work with both of them. So you can either add Fe2 plus or Fe3 plus, and once you add that this reaction, it's going to be a homogeneous catalyst because Fe2 plus or Fe3 plus would be in aqueous state. These ions, your ions over here, S2O8 2 minus and I minus 1 are also in aqueous state. So it's an example of a homogeneous catalyst. So if you add these two, any one of these two ions, these two ions are going to catalyze this reaction. Now we're going to discuss how a homogeneous catalysis in this particular case is going to occur. Now what happens is, when you add either Fe3 plus or Fe2 plus as a catalyst, now Fe3 plus or Fe2 plus, they're going to take part in the reaction. So initially the reaction was occurring between our S2O8 2 minus ions, which is over here, and I minus 1 ions. But when you add Fe3 plus or Fe2 plus, these ions are going to interfere. They're going to take part in the reaction. So what happens is, we already discussed that S2O8 2 minus and I minus 1 are not going to react together. The reason why they're not going to react together is that I minus 1 and S2O8 2 minus are both negative ions. They're going to repel each other. So they're not going to react together. So what they do instead is, instead of reacting with each other, start reacting with Fe2 plus or Fe3 plus sign. So let's look at these two equations first. You have I minus 1, it has the lower potential, which means since it's a lower potential, it's going to lose electrons. So I minus 1 ends up losing electrons, whereas Fe3 plus starts gaining electrons. So the first part of the reaction is that I minus 1 ends up losing electrons. It's going to get converted into I2, whereas Fe3 plus starts gaining electrons, and I would have to multiply Fe3 plus by 2 so that the number of electrons gained and lost are equal, and it starts forming Fe2 plus. Now half of your reaction is complete. That half is that I minus 1 got converted into I2. So I minus 1 got converted into I2. That was one of the products. But in the meantime, all my Fe3 plus, which I added initially, has been converted into Fe2 plus. So let's say this is my first step 1 of the reaction. So this is step 1 of this reaction. So what happens in step 2? Let's rub this off. So what happens in step 2 is that these two, S2O8 needs to react with something. So it starts reacting with the Fe2 plus ions that are formed. And if you look at the equation, this is the higher potential, which means that S2O8 is the one that's going to gain electrons, and this is the lower potential. So that means Fe2 plus is the one that's going to lose electrons. So the Fe2 plus that are formed in the previous step, they will then start reacting. It's going to react. Fe2 plus would then be converted into, it will be converted into Fe3 plus. And I would have to multiply that equation by 2 so that the number of electrons gained and lost are equal. Whereas S2O8, 2 minus, gets converted into 2SO4, 2 minus. Now that was my second product. My second product was SO4 2 minus. So what Fe3 plus did was, if you look at Fe3 plus initially and later on, it remains unchanged. It got converted into Fe2 plus in the first step, and when the second step occurred, when I wrote down step 2, that Fe2 plus got converted back into Fe3 plus. So my catalyst, which was in this particular case, I'm using Fe3 plus. My catalyst remains unchanged. So my catalyst remains unchanged, whereas both my reactants, one of the reactants was 2I minus 1. That got converted into I2, and my other reactant was S2O8 2 minus, and that got converted into SO4 2 minus. So what Fe3 plus did in this particular case was that it broke down the reaction into 2 steps, and instead of I minus 1 and S2O8 2 minus reacting with each other, they started reacting with Fe2 plus and Fe3 plus. So in the first step, I minus 1 reacted with Fe3 plus and got converted into I2, and that Fe2 plus that was formed in the second step, it reacted with S2O8 2 minus and got converted into Fe3 plus and SO4 2 minus. So the Fe3 plus that was initially added remains unchanged at the end of the reaction, and both my products are formed. And this reaction would have a lower activation energy because in both the steps, the reactants that are reacting are both oppositely charged ions, so they're going to attract each other, and this reaction would occur at a very fast speed compared to the previous reaction that was not occurring. The reason being that I minus 1 and S2O2 minus were negative ions, they cannot attract each other. They would be repelling each other.